In this lesson video for day 3B.5, we're going to be talking about quadrilateral proofs. We're going to be using all these properties that we've been talking about with quadrilaterals and going back and using them in proofs. So the proofs themselves are not anything that are a whole lot different than what we've done already. In fact, most of what we are proving involves proving triangles are congruent or that parts of triangles are congruent, but we're going to be using the properties of parallelograms to help establish that those triangles are congruent. So I want to start by reviewing some things and helping you remember that if you're given a classification of a parallelogram, rectangle, rhombus, or square, or even a trapezoid, you can use these properties of the shapes as reasons to state that things might be congruent. Okay, you can use the fact that sides are congruent or parallel. You can use the fact that angles are either congruent, supplementary, or maybe bisected. You can use bisectors, congruent, bisector, perpendicular. You can also use right angle classifications. All right. Okay, so we can add that one in. You can, when we talk about perpendicular segments or right angles. Okay. All right, and those are some classifications we might need. So let's go ahead and move on to the next page and actually do a quick little review of triangle congruence. We had 5 ways that we could prove triangles are congruent, and hopefully you remember what those are, but I'll kind of write those in for you here. You had side, 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 angle, side, angle, side, angle, 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 side, and HL for hypotenuse leg. Okay, now after those 2 triangles are stated to be congruent, what property allows us to write that any of the other congruent statements for angles or sides? That should be CPCTC. Corresponding parts of congruent triangles are congruent. So this is kind of tying back into the proofs we did in the last unit. So here's what we're going to do now. Okay, we're going to practice just using some of these properties and doing some sketches to understand some things about what they tell us. In examples 1 through 4, we're using the fact that there is a quadrilateral, ABCD, that is a parallelogram. So we're identifying properties of parallelograms for this. Okay, and the diagonals intersect at point X. So the first thing we're going to do is draw that and label it. Okay, so we're going to draw a parallelogram. Okay, doesn't have to be perfect. We're going to label the 4 corners A, B, C, and D. And it says the diagonals intersect at point X. So I'm going to draw the diagonals in. And they intersect at point X. Okay. Now, we want to name all the information you can about the sides. Well, remember what we know about sides of a parallelogram. Opposite sides are parallel. So I can say AB is parallel to CD, and I can say that BC is parallel to AD, but we also know opposite sides are congruent. So I can say AB is congruent to CD, and BC is congruent to AD. Okay, that's all I can tell about the sides here. But then number 3 says to name all the information we can about the angles. Well, we need to remember that in a parallelogram, opposite angles are congruent. Okay, so I can say angle A is congruent to angle C, and angle B is congruent to angle D. But we also know that consecutive angles are supplementary. So I can write these 2 equations. The measure of angle A plus the measure of angle B equals 180. It's actually 4 equations I could write. The measure of angle B plus the measure of angle C equals 180. The measure of angle C plus the measure of angle D equals 180. And the measure of angle A plus the measure of angle D equals 180. There's 4 different supplementary angle relationships I could come up with. And then finally, we want to name all the information we can concerning the diagonals, okay? Now, I want you to remember what we know about diagonals in a parallelogram is that they bisect each other. So we can even write that in words as the property. Okay, the diagonals bisect each other, but that gives me congruent segments like AX is congruent to XC, and BX is congruent to XD. Okay? I could even mark those kinds of information here. I could mark the opposite sides congruent and parallel, like that. And then these two congruent and parallel, like that. And then I could use another set of congruent markings to say that these are congruent. And then a fourth set of congruent markings to say these are congruent. Okay, and so that's really how we would mark a picture of a parallelogram with all that information. And then I could mark congruent angles, but then it's going to get really kind of messy to look at. All right, another set of examples here. In this one, we are given quadrilateral ABCD is a rhombus. Okay, rhombus. We're going to draw that. That is, again, drawn like a parallelogram, but I'm going to try and make all four sides look like they're the same length. Okay, so that's a rhombus, and it's called A, B, C, and D. And the diagonals intersect at point X. Okay, we're going to go through and do the same thing. We're going to name all the information we can about the sides. Well, all four sides are congruent this time. So I can say AB is congruent to BC, is congruent to CD, which is congruent to AD. And then opposite sides are still congruent, or still parallel. AB parallel to CD, and BC, that didn't work out right, there we go. BC is parallel to AD. Okay, and that's what we know about the sides. The angle measures, again, we know opposite angles are congruent again. This time I'm just going to write out the properties. Opposite angles congruent, like A and C, B and D. We know consecutive angles are still supplementary because it's also a parallelogram. But this time we know the diagonals bisect opposite angles. Okay, so I know that I've got angle BAX is congruent to angle DAX. Okay, those are congruent there. Just like these are also congruent. And so actually all four of these parts are congruent. So angle BCX, and then it's also congruent to angle DCX. All four of those are congruent. And then we have congruent angles here, 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 and here also. So angle ABX is congruent to angle CBX, and those are congruent to angle ADX, which is also congruent to angle CDX. Okay, but one other piece of information that is important about our angles here is that we have right angles at X. Okay, these are all right angles because the diagonals are perpendicular. Okay, so that kind of leads us into number 8 here. Name all the information we can concerning diagonals. Okay, diagonals still bisect each other into congruent segments. So X is the midpoint of both diagonals. And we know that the diagonals bisect opposite angles, like I just pointed out over here. But we also know that the diagonals are perpendicular. Remember, that symbol means perpendicular. Okay, so there's all that information that could help us out in some proofs. So let's actually get into an example or two that use proofs. All right, so as we look at number 9 here, we are given ABCD is a rectangle, and we are given some other information about that. Okay, we're told that BC is congruent to CD. So I'm going to actually mark that. BC is this segment, and CD is this segment. Those are not diagonals of a rectangle. Okay, those are just extra segments that have been put in there. We're trying to prove that AC is congruent to CE. Now, those are parts of one side of a rectangle, but they're also sides of these two triangles here. So I'm going to use those two triangles, prove that the triangles are congruent. So I'm actually going to kind of make some notes here. Okay, first, prove triangles congruent. Then we're going to use CPCTC to show that these sides are congruent. Okay, so for the first part of our proof, we're going to start with the given. Again, with a proof, you can always just copy this given line down. Okay, copy all that and write the word given as your reason. And that'll get you at least a partial point or a point when it comes to tests and quizzes. Okay, so we can start with that given information. A, B, C, D is a rectangle. Can't spell. There we go. Let's try that again. It's a rectangle. We can abbreviate. And BC is congruent to CD. That's all given information. Well, in order to prove these two triangles are congruent, it doesn't look like we're given a whole lot of information. I can't use these two things to say the triangles are congruent. But I do know, let me zoom in so we can see this a little better. I've got opposite sides of the rectangle that are sides of these triangles. So those would have to be congruent because opposite sides are congruent. So I'm going to say that next. Okay. I can say that AB is congruent to ED. Okay, and that's because opposite sides of any parallelogram, including rectangles, are congruent. Okay, and that gives me another pair of sides. Now, another thing I want to look at, if I were to try and use side, 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 I would need these sides to be congruent. However, these, I can't use that. That's what I'm trying to get to at the end of my proof. So what I'm actually going to do is remember that this is a rectangle, which has 4 right angles, which makes these two triangles I'm using right triangles. And remember, in right triangles, we can use HL. I've already shown hypotenuses are congruent. There's the H. And then these here are the legs congruent. Okay, so I've shown enough to say that, but I have to state these are right triangles first. And the reason they're right triangles is because rectangles have 4 right angles. Okay, so I can say that triangle ABC and triangle DEC are right triangles because in any rectangle, there are 4 right angles. Okay. There are the hypotenuses that are congruent. There are the legs that are congruent. So now I can say triangle ABC is congruent to triangle DEC because of HL, which then I can say that those segments AC and CE are congruent because of CPCTC. Now, I've caught a little mistake in the notes here that I haven't fixed yet, and I apologize. In the beginning, I said that ABCD is a rectangle. This is not ABCD. That's not a rectangle. ABDE is your rectangle. ABDE is our rectangle. So I'm actually going to fix that. ABDE. So just kind of fix that. It's not a big deal. I wouldn't count off points if we didn't fix that on a test or quiz, but it does need to be pointed out. Okay, so as we continue, this time I'm actually going to tell you what I want you to use to prove these triangles are congruent, and actually that's where we stop with our proof. And all we have to do is use side, side, side here. So this one's going to be a little easier. We want to start with our given information. ABCD, labeled it correctly this time. ABCD is a rhombus. That's given. And that's all that's given to us, but all of the properties of a rhombus apply to this. So I'm going to have us trace to specify which triangles we're using. AED and CED. Now, I could use several different methods for proving these triangles are congruent. I could use HL here because the diagonals are perpendicular. That creates those 4 right triangles inside there. But I don't need to in this case. In this case, I'm just going to use side, side, side. And here's one of the reasons that sides would be congruent. In any rhombus, all 4 sides are congruent. So AD and CD are congruent. AD is congruent to CD. There's a pair of congruent sides because 4 sides of a rhombus are congruent. And that's our reason. That's our property of rhombi that we used to say that all those sides are congruent. We also see that these two triangles share that same side. There's a common side, ED. I can say ED is congruent to ED because there's a common side. Or we also call that the reflexive property. The only thing left to look at are these other pairs of sides, and that's these two sides. Well, those are two parts of the same diagonal. Because a rhombus is a parallelogram, we know the diagonals bisect each other, which makes AE congruent to EC since diagonals bisect each other. Okay, there's my pairs of side, side, side. So I can say side, side, side congruence for these triangles. So triangle AED is congruent to triangle CED by side, side, side. And that finishes that proof. Okay, we just have one more to look at. And so let's turn to the last example in the notes. And this is a very unique kind of proof, but it's going to work the same way for any regular polygon that we work with. And you're going to see a very similar proof to this again on the review, on the assignment, and again on the test. So it follows a very simple format. We're just going to prove that two triangles are congruent, but we're using some new terminology. And actually, we've done this way back in the year. We talked about an inscribed regular polygon, and this is where we see it again. So we're told that ABCDEF is a regular hexagon. Okay, remember that means 6 sides. Okay, it's a regular hexagon inscribed in circle Y. What that means is every vertex of the hexagon is on the circle. Okay, and it's a regular hexagon. All 6 sides are congruent. We also know that because it's an inscribed circle, every one of these segments here from the center of circle Y, which is point Y, every one of these segments that goes out to another point is called the radius of that circle. And the radius is going to be the same no matter which point it's going to. Okay, so that's going to give me a whole lot of other congruent segments. All right, and so we're looking at triangles EYD, EYD, looking at that triangle, and CYB, CYB. Okay, I'm looking at these two triangles, and I want to prove that those are congruent. The easiest way to do that is going to use side, side, side here. All right, so we're going to start with the given. Okay, we're going to say ABCDEF is a regular hexagon inscribed in circle Y. That's a short way to write that. Okay, that's all our given. Now, because it's inscribed in a circle Y, every one of these segments that touches point Y in the middle there is a radius. Okay, and because every one of these is a radius, that means they're all the same length. They got to be congruent to each other. That's what a radius means. It's the same distance all the way around the circle. So we can actually use something called the definition of the radius to say that those segments are congruent. Well, I can just start pairing up matching sides. EY and CY have to be congruent. EY is congruent to CY because they're a radius. So that's definition of radius. Okay, EY to CY. And the same thing for DY and BY. DY has to be congruent to BY for the same reason, definition of a radius. Okay? Now, the only other pairs of sides to talk about are these two sides, ED and CB, but those have to be congruent because it's a regular hexagon and all sides are congruent in a regular polygon. So I can say that ED is congruent to CB, and that's definition of regular hexagon. Okay, definition of a regular hexagon makes those congruent. Well, I've shown side, side, side now. I can say triangle EYD is congruent to triangle CYB because of side, side, side. Okay, now most of your proofs are going to work out very similarly to this. Remember your properties of quadrilaterals, parallelograms, rectangle, rhombus, square. But for this specific proof, these are the only reasons you need to remember: definition of radius and definition of regular polygon. Could be a hexagon, octagon, nonagon, doesn't matter how many sides there are. If it's a regular polygon inscribed in a circle, we're going to use a proof very much like this.